Kepler's inverse problem allows us to easily find the exact distance to a planet using its orbital period. Saturn completes one full revolution around the Sun in a record-breaking 29 Earth years. Simple mathematical calculations prove the colossal distance of the giant planet from our central luminary. The discovery of these laws forever changed humanity's understanding of the incredible scale of infinite space.
For centuries, if you looked up at the night sky, the planets were just these wandering points of light. We could watch them, track them, but no one had any idea how far away they actually were. Today, we're going to see how a single, almost shockingly simple mathematical law unlocked the true, staggering scale of our solar system.
It all comes down to this one fundamental question. How do you measure something that you can't possibly get to? I mean, you can't exactly run a tape measure out to Jupiter. This is a classic scientific challenge called an inverse problem. The whole trick is to use something you can measure, like time, to figure out something you can't, like distance.
So here's our roadmap for this explainer. First, we'll dig into that cosmic inverse problem. Then we'll uncover the elegant solution, what Kepler called the harmony of worlds. We'll actually run the numbers for Saturn to see it work. After that, we'll grasp what this revelation truly meant for our place in the universe. And finally, we'll touch on a really important distinction between observation and gravitation.
All right, let's start by framing this core challenge. Early astronomers were fantastic observers. They could patiently watch a planet and time its full orbit, the how long it takes to circle the sun. But the real prize, the how far, was completely out of reach.
Think about it like this. Picture yourself standing on a shore, watching a ship sail across the distant horizon. You could easily time how long it takes to go from point A to point B. No problem. But could you tell me if that ship is 1 mile away or 10 miles away? Nope. Not without some other piece of information linking time and distance. That was the exact same problem we had with the planets.
So what was that missing link? What was the key that finally unlocked this whole cosmic puzzle? Well, it came from the brilliant mind of Johannes Kepler and his discovery of a deep, beautiful mathematical harmony governing the planets.
And here it is, Kepler's third law. It looks so simple, right? T squared equals A cubed. T is the planet's orbital period, how long it takes to go around the sun, and A is its average distance from the sun. Now, for this elegant little equation to work, we have to use very specific units. T has to be in Earth years, and A is measured in what we call astronomical units, or AU. 1 AU is simply the average distance from the Earth to the sun.
And this is the whole point. What this law really tells us is that these two things, a planet's year and its distance from the sun, are not independent. They are fundamentally, unchangeably linked. This formula created a mathematical bridge. It let us take the one thing we could see, time, and cross over to the one thing we couldn't, distance.
Okay, theory is great, but let's put this law to the test. Let's see its predictive power in action by running the numbers for a real planet. We'll pick the ringed giant Saturn.
All right, here's our setup. We have our target, Saturn, and we have our one piece of observable data, its sidereal period, or its year. We know from observation that it takes Saturn about 29.46 Earth years to make one full trip around the sun. Our goal is to plug that number into Kepler's formula and find A, its average distance in astronomical units. And the calculation is beautifully simple, just 2 steps. First, we take the period, T, and square it. So 29.46 times 29.46 gives us about 867.89. Easy enough? Now we know that T squared equals A cubed. So to find A, we just have to do the opposite of cubing a number. We take the cube root of 867.89.
So we run that calculation and we get a number. But what does that number actually mean? This is where the abstract world of math suddenly reveals the immense and very real structure of our solar system.
The answer is 9.54 AU. Now remember what an AU is? It's the Earth-Sun distance. So this result tells us that Saturn is on average 9.5 times farther away from the sun than we are. Right away, you start to get a sense that the solar system is much bigger than you might have imagined.
But let's make it even more real. We know that 1 AU is about 150 million kilometers. If we do the conversion, that means Saturn is orbiting the sun at a distance of over 1.4 times billion kilometers. Suddenly, that number isn't just a number. It's a tangible, mind-bending scale of emptiness and distance.
And that was the revolution. No, they couldn't reach Saturn with a tape measure. But with this elegant formula, humanity for the very first time got a glimpse of the true map of our cosmic neighborhood. The old idea of a cozy, compact cosmos was shattered. It was replaced by a reality of vast, colossal emptiness between worlds.
Now for our final point, and it's a really important nuance in how science actually works. We need to understand where Kepler's discovery fits into the bigger story, because it highlights a critical difference between two types of scientific breakthroughs.
You see, Kepler's law is what we call an empirical law. He derived it by spending years poring over the incredible observational data collected by Tycho Brahe, and he found a mathematical pattern that just fit. It worked perfectly. He knew that it worked, but he didn't know why. It was decades later that Isaac Newton came along and provided the why. Newton showed through his theory of universal gravitation that Kepler's laws weren't just a coincidence, they were a necessary physical consequence of how gravity works.
And that leaves us with a pretty profound final thought. A simple formula, t squared equals a cubed, revealed the hidden architecture of our entire solar system. It really makes you wonder, what other incredible cosmic truths are out there, just waiting for us, hidden in the language of mathematics?
Thank you, friends. Strive for understanding and become wiser. See you soon.